Okay, all right. So before we uh, start developing projects using ML methods, so we need to go over how to create environment managers in Python and some installation of some packages like TensorFlow and PyTorch we'll see. So, right. So first, the prerequisites. This assumes like everyone has a Linux OS with Bash shell, but if not, I mean, this should work fine on Windows or Mac or any other operating system, but Linux is recommended. And today we will go over this Python environment manager, specifically two of them, Miniconda and virtual env. And then we will see how we can install some Python libraries in those environments. Right. So let's begin. So what are environment managers first? So these are like tools to create different Python environments. You can think of it as like some different directories which are independent from each other, which have specific Python version and different packages and modules, each of which are independent from each other. Right. So first of all, it's recommended not to use the system Python installation. That's why we create different Python environments. But apart from that, it offers many other advantages also. So like first is dependency management. So if different projects require different versions of certain packages, then we can create different environments and work in those, and there will be no conflicts. So also we can work on some project in isolation, and not only does that offer you that it's not talking with the systems environment and all this, but that also offers some reproducibility. So if we are developing some project in a specific environment, we can share that environment with other people, and that code should work fine in that environment, right? So mainly we have Miniconda or Anaconda and this Python virtual environment. So we'll use virtual env package, which is a third-party library, not the venv module. So this venv module comes along with Python, I think from 3.7 onwards, but we'll use this virtual env. Using Miniconda is recommended, although it has a larger size footprint, as we will see, because Miniconda uses something called this Conda repositories, and it comes along with many other packages itself. So a larger version of it is called Anaconda. So the difference is that Anaconda comes along pre-installed with a number of packages that might be helpful for data science purposes, and Miniconda is just a minimal version of that. And Python virtual environment, this uses pip. So there are some differences between these two. So using Conda, you see that it doesn't require a compiler on your system because it comes with its own pre-compiled binaries that Conda package manager manages and installs itself. And whereas pip installs from, as you see, this PyPy, this Python package index, where all the developers post uh, their codes. So this is Python's default place. So what this does is like does source installation. So it takes from PyPy and then compiles on your system. So often what happens is that if we install some package before and then some other package later, so there might be some conflicts among them. So that dependency conflict also Conda manages by itself. Apart from that, Conda has not only just Python packages, it comes with C++, R, and different packages also. And Conda can by itself create environment. Uh, pip cannot. We require like different modules to do that, like we'll see virtually env. And so the place from where Conda installs package is its default Anaconda repository. And there are other also third-party cloud services like you will see when you install the most popular for data science and in our case high energy purposes would be Conda Forge, right? So let's apart from these two, we can also do some work on Google Colab. This comes pre-installed with certain packages. So this we can see. I have something open. So if you can just go on this link, I'll share the slide or you can just search. So this comes with TensorFlow and PyTorch, all of this installed. So you can run it on here also. And you can also run pip here, I think. So if you have to install something, as we'll see later, we can install in Google Colab environment also. And this also offers, I think, apart from CPU, we can change the runtime to GPU and something that will come later. But yeah, let's move on. Right. So to install Miniconda, either you can go on this link or just Google like download Miniconda. And so in these slides, we'll follow this description. So where this $sign is, that means it's a command in terminal, and this hash is for a description of that command. Right. So after we have downloaded this Miniconda installer, we can go to the path where it's downloaded and just do bash and the name of the file in that directory, and that should work, and that will install Miniconda. We will just follow the instruction, and whatever the prompts are given by the installer, we can just type yes, and it's also recommended to install in the default location. So if you just follow the prompt, this will be done. Right. So once we have downloaded and installed Miniconda, we'll need to create different virtual environments. And to create different environments is very simple. You can just write a command like this: conda create -n and the name of your environment and Python. And we can do a lot more with this, as we will see. So, and then after doing this, we can just follow the prompts and that will be done. So for example, if we want to create an environment named ML4HEP, so we can do this: conda create -n ML4HEP, and then Python with a specific Python version. So let's say we want 3.10. So we can do that. We can do any other versions and other things also. So after this environment is created, to work in that environment, we need to activate it, which we do by this command, conda activate and the name of your environment. And after you are done, you can close that environment by conda deactivate. Uh, so some other commands, like you can do conda env list, and this should tell you the name of the list of all the environments that are on your system. And to delete an environment, we can do conda remove -n name of your environment, and then all. So there are a lot more commands to do useful things with conda, which you can find on this link. This is a conda cheat sheet. So, but mostly after you have done this, and as we'll see how to install packages, so that's most of what we'll require for our purposes. Right. So after we have created an environment, we can install packages in that environment. So the command for that is simple. You can just Google what package you want to install and then type conda. So I'll show you. But for example, let's say if we want to install matplotlib and scikit-learn, so we can just do conda install matplotlib scikit-learn after activating our environment. So this would install these two packages in our environment. But if you just Google something like this, right? So you'll find an Conda link, and you'll find what command to run to install it. So here it says conda install conda forge matplotlib. So this is slightly different because this uses, as I was saying, this conda forge channel. This is a third-party channel not maintained officially by Anaconda, but conda forge is one of the primary sources for data science people. So this is very reliable. Right. So apart from installing packages after creating an environment, we can install packages while creating the environment itself. So let's say if we know that we want TensorFlow and NumPy in our environment, so we can run this command. So conda create -n ML4HEP, and then Python, you can type specific Python version also, and then TensorFlow and NumPy. But while running this command, you will see that it doesn't work out. You'll find some errors, and it will show some incompatibility issues, because NumPy version 1.19 doesn't work with this TensorFlow. So since we haven't mentioned any specific version for TensorFlow, it would take whatever the latest one is available. So I think it's 2.2.16 or something. So that is not compatible with this version of NumPy. So it will prompt you to either choose a version that is compatible with TensorFlow, or redo this environment creation process. So if you want to get away with this, you can just remove the version number from NumPy, and then Conda would itself choose whatever packages there are which have no conflicts among each other. So this works out fine for if we have like a small number of libraries. But let's say if we have a large number of packages that we know we have to install in environment. So we can also do that in one shot by using a YML file. So that I haven't mentioned here, but if someone wants to know, I mean, you can ask me, I can show you. So you just create a YML file like, I have some example, right? So you create a YML file like this with name and what channels you want to install from and what packages you wants to install. And then on the Conda website, you can find some command. So Conda create -f and the name of that file. And that would make your environment with all those packages in one shot. So the advantage of doing that in one shot is that if there are any conflicts, you would know beforehand. Whereas once you create an environment and do Conda install repeatedly, there might be some issues later on. Right. So that's all for Conda. So another way of doing this is by using this virtually env. So virtually env uses pip as we talked before. So pip is the default package installer for Python. Right. So if you have installed anything from now, you might have encountered it doing pip install or something. So most Linux OS comes pre-installed with pip. You can check this by running which pip3 in your terminal, and this should show you something like this. But if not, you can just install by doing sudo apt install python3 pip. Right. And we need pip to install virtually env because this is a third-party library. So after installing pip, we can run pip3 install virtually env. And this should install virtually env. And after this, we can create an environment simply by writing virtually env and the name of our environment. So this would create an environment named this env underscore name in our current working directory. So then we can activate the environment by doing source name of the environment /bin/activate. And then we can check if we are in the correct environment by running this command. So name of our environment, which pip3. So this should show you the path to that directory and then the environment name, then bin pip3. So this would be like a sanity check that we are in the right virtual environment. Right. So after we have created the virtual environment and done this source uh, environment name bin activate to enter into that environment, we can install packages just by writing the environment name pip3 install and name of the package. So environment name pip3 install TensorFlow and so on. Right. So apart from these things, later on we'll need PyTorch. So also since Jupyter is omnipresent now, you can just install Jupyter also by running conda install Jupyter or pip3 install notebook in your environment. So these things, if you think it's different, it's Jupyter for conda or notebook for pip3, you can just Google it and you'll find like very easily. Right. So apart from TensorFlow, we'll need to install PyTorch. And so you can either Google or go on this link and right. So PyTorch, if we just follow this link, we'll have this kind of a window and we can select what the things are that we want to install. So let's say our OS is Linux, we want to install via Conda and for Python and for CPU only. So it will give us some command and we can run this conda install PyTorch, torch vision, torch audio, CPU only, -c PyTorch. So this would install PyTorch, torch vision and torch audio. Right, but if you have dedicated GPU for training ML things, so if you have NVIDIA GPU, you can do this command NVIDIA-SMI to check which CUDA version you are running on. And then, so if you have GPUs, then you can select CUDA from here and then install the GPU version of PyTorch. So this will be a little bit faster than running on just plain CPU, right? So similarly, after PyTorch, you can install PyTorch Geometric. I think that will also be needed in the tutorials. So similarly, you can do Linux, uh, either conda or pip, and then just run this conda install pyg. Right. So apart from this, after you have done with the installation and creating environments and installing, So you can follow like these websites have very nice basic examples. So you can follow this and check if it's working and also learn something. So yeah, that's all. So if you have any questions, then or if someone had any problem while doing something like this, then
Sir, what is PyTorch geometric for?
oh, okay. So right. So you can think of it as like there is something called geometric deep learning, right? So PyTorch would work with what we say in ML term. You'd hear these tensor objects, right, which are just matrices. So these are homogeneous objects. So their structure is like array-like, but sometimes, often you have things like graphs or something which does not have a uniform structure. So you use PyTorch geometric for those purposes.
Okay, sir.
Right. You can just go and so these websites also that I've mentioned, so they have very nice examples. So you can follow the basic example and you'll see. So this kind of a thing, it will be very difficult to handle via regular TensorFlow or PyTorch because you'll have to create a very large matrix and so on. And also just call me Deepanshu. Yeah.
So, sir, in the Google Club, we have to also, install the virtual
No,
environment, or we can
no, you
directly.
don't need to. You don't need to install virtual environment in Google Colab. So because it's an independent notebook, right? So this comes with like TensorFlow or I think also with PyTorch. Uh, but some of the packages might not be there. So you can do like pip. So pip would work here, right? So if you're using Google Colab and there is some package that is not uh, pre-installed, so then you can just do pip here. And then in this notebook or this running instance of this notebook, you'll have this package available. So now you can,
Okay, sir.
yeah, right.
How to
So
know that the TensorFlow is already installed or not in my Conda environment?
So, so that I mean, either you can check the documentation for how Google Colab does it, but it has been made for those purposes only. So TensorFlow and PyTorch and NumPy and all this will be pre-installed in like if you open any notebook in Google Colab. But some of the less known packages might not be. So then you can just do this pip install.
No, I'm not talking about Google Colab. Like, let's say
Oh,
I have my Conda environment and I want to know that is it installed or not. So,
oh, I mean, you can just open Python and so if you are in some like uh, let's say you are in some Conda environment, right? So you can do conda list also. So this is one command that would tell you what are the packages that has been installed. So either you can find, so we see TensorFlow here, or what you can do is just like run Python and then try to import it. So if you find some error, then it's probably not installed. So here it worked. So yeah, but conda list, you can do conda list and check what all the packages are installed in that environment. But if you haven't installed it by yourself while making the environment, then probably it wouldn't be there. Right. So if there are no more questions, then we can end this. And tomorrow, I think Vishal will take a TensorFlow tutorial. So running some simple examples and all this.